Their Durham crop with that winter triticale is waist high. Neighbors that are using BMPs and other agronomists is boot high under drought stress. The chickpeas and the wheat were able to intermingle and have the mycorrhizae. The chickpeas were sharing the water with that wheat crop to keep it alive. Where they had the barrier between, the wheat died. When we have plant diversity, we have the mycorrhizae, we have this functioning system, now that drought tolerance disappears. The joys of what I do is I deal with everybody all over, dealing with different moisture. So, up in the northeast Saskatchewan, where there's lots of flooding, and I also deal in the southern part of the province that are really, really dry. And one of the things that we really have to get our heads around is something called the micro water cycle. And one of the things we've been doing in the southwest part of Saskatchewan is putting a little bit of winter wheat or winter triticale in with their Durham at the same time seeding. And we're talking, once again, being cognizant of moisture concerns. So we're cutting back the seeding rate of our cash crop by that 10 to 15%. And if we're really overseeding, maybe more, we need to create a little bit of room for this cover crop. And so having that biennial grass plant growing underneath, it's going to be shading the soil. We're talking about 1 to 2 plants per square foot, so it isn't a really dense crop. It's not going to use a lot of water, but what it's going to do is it's going to shade the ground. It's going to reduce the evaporation, and with the mycorrhizae, you're going to get the soil functioning a little better. The other thing with it, the micro water cycle, is those leaves, those green leaves above the ground. When the air temperature starts dropping, we're going to get water condensation on those leaves. So if that winter triticale plant is under drought stress, it'll absorb that water, photosynthesize, and release that water as a root exudate along with the other root exudate products. And so, yes, it's going to use a little bit of water. Yes, it's going to use a little bit of nutrients, but because it's going to be firing the biology for a longer period of time, it's going to be reducing our evaporation. It's going to be increasing our soil aggregate stability. It's actually a net positive. And so some of the pictures that producers have been sending me is, their Durham crop with that winter triticale is waist high. Neighbors that are using BMPs and other agronomists is boot high and under drought stress. So when we start looking at that system, it's a little bit of diversity seeded at the same time as a cash crop. The other thing that we need to do is have some deep-rooted taproots and of some biennial plants that are mycorrhizal. And what's going to happen is there's some studies, and John might know the source of this. It was in the Midwest somewhere. They had towers of soil, wheat and chickpeas growing together. And in the next one, there was chickpeas and wheat growing together, but they had a barrier between the two plants. So these towers were out of 6-8 feet tall, whatever they were, and they induced drought stress on these two plants or two towers. Where the chickpeas and the wheat were able to intermingle and have the mycorrhizae, the chickpeas were sharing the water with that wheat crop to keep it alive. Where they had the barrier between, the wheat died. So when we have plant diversity, we have the mycorrhizae, we have this functioning system, now that drought tolerance disappears. Adding it in after establishment of your cash crop in dry conditions, very high risk. So we need to see it at the same time. We need to have that functioning plant system going.
John, you had muted there. Go ahead.
Yeah, Kevin, I love your detailed answer. I love your answer, and it's I have many. There's so much nuance here, but I'd like to point out 2 principles that people may not be thinking about. The first is we've been taught historically that plants are always inherently going to compete with each other for water and nutrients. And what you so eloquently pointed out, and what many people have observed and experienced, is that that is not true by default and by definition, that there are plants that can collaborate and share water and share nutrients with each other. And the better job we do of identifying exactly what those species are that have this collaborative effect rather than a competitive effect, that's where we really harness the power, this amplification of the micro water cycle that you so eloquently described in driving more water availability for the crop that we're harvesting. So that was very well articulated. And then the other point, you mentioned it, but I think it's so easy to pass it on by. We don't think of sugar as water storage, but it is. When plants photosynthesize, they are storing water as sugars. And when those sugars are sent out through root exudates to feed biology, biology can actually disaggregate those sugars and turn it back into water. This is something that Bruce Tainio talked about 30 years ago, and it's something that I've observed as well, is that you can actually have water generation in soil from sugar and carbohydrate decomposition.